This video explain example 1 in week 3 lectures. It has a rectangular industrial building that is shown here, situated in industrial area, is to be designed, which is in Sydney. The building has a height of 4.5 meters and a size of 10 meters by 40 meters. The building has a flat roof supported on the load-bearing walls. So the orientation of building is north 30° east, which is north 30° east. Determining the design wind speed, so we need to find a design wind speed for this building. Given data, return interval is 500 years, terrain category is 2, no shielding effect, and the building is located on the flat ground, so it's not located on the mountain or anything else. So that's the examples. Now it's asking to find design wind speed. Now to find the design wind speed here, we are going to use the Australian standard ES NZS 1170.2. I can show it here. Now that is on the page number 9 on the Australian standard AS NZS. I can zoom. Now to calculate the design wind speed, we first need to calculate the site wind speed. Now the equation for the site wind speed is given on here, which is on the page number 9, and from the site wind speed we calculate the design wind speed. But to calculate the design wind speed, they have given notes here. The building orthogonal design wind speed V design theta shall be taken as a maximum cardinal direction. I will explain what is maximum cardinal directional site wind speed V side beta linearly, and interpolating between the cardinal points within the sector plus or minus 45°. That also I explain in the later in the video, with the orthogonal direction being considered. Okay, so we just need to look at the plus 45 plus and minus 45°. Now to start this example, now here we are going to follow some steps to solve these examples. Now as I mentioned, we have I taken the these equations, like design wind speed is equal to maximum of V side beta equal to, we need to get the maximum value of VR, MD, MZ cat, MS and MT. Now this is the MD value. We will find the various MD value, but we need to get the maximum MD value to get the maximum site wind speed. That maximum site wind speed is our design wind speed. Now these equations, which is site wind speed, as I mentioned, that site wind speed is taken from a Australian 1170.2, and that V side beta is equal to VR, MD, MZ cat, MS, MT. That's exactly the same thing I copied here, and I also write here section 2.2 on page number 9. Now to solve these problems, we need to find this design wind speed as I given in the questions, that we need to find this design wind speed. Now to find the design wind speed, we need to find the various site speed. Now first of all, we need to determine the region. Now it's given in the question is Sydney. So I put the note Sydney. Now we need to find the region. Region is A2, which is given in figure 3.1 on page number 16. I can show it on page number 16 on the Australian standard 1170. You can see these Australian maps where you can locate Sydney, and the Sydney is in region A2. So that's how, based on the locations, we can find which region the buildings need to be designed. So now it's in the region A2. So therefore I put the region A2, figure 3.1 and page number 16. Once you find the region A2, you can find the regional wind speed, which is VR. Now the regional wind speed, before you find the regional speed, we need to get the return interval, which is 500 years. Now if you go in the questions, we have in given data, we have return interval of 500 years, so that is R 500, and the region is A2. Now use the Australian standard again. In the table number 3.1, we can find regional wind speed VR equal to V 500, which is interval equal to 45 meters second. So if you check it on the Australian standard, we have a table number 3.1. We have a regional wind speed. where we have a different regional wind speed. So this is the VR, which is the return interval 5 years, return interval 10 years, return interval 20 years, 25 years, and so on. In our example, return interval is 500 years, so that is 500 V500. Now we are looking in the non-cyclic region, so we are dividing our region into two categories. One is the non-cyclic and cyclic, but here our example is non-cyclic region, which is in Sydney, and we have A2 region. We found A2, so A1 to A7, this is W region, this is B region. So A2 is in these columns, and we can check V500, which is 45, and the unit is meter per second. So the 45 meter per second, that is VR, that is a regional wind speed that is given here. VR is 45 meter per second. Now that is your 45 meter per second. That is your regional wind speed. So we just found the regional wind speed here, the first category. In the next video, we will look at those other values. Thank you.